Hello, this is Mrs. Decker, and in this video I'm going to go over 3.2a on the types of chemical reactions. So we have 5 different types of chemical reactions, and looking at the patterns that you see in the chemical equations, you should be able to determine the type of reaction that it is. All 5 types of reactions follow a very specific pattern. The first type of chemical reaction is called a synthesis reaction. So synthesis literally means to make or to bring together, to create. So that is what we're doing in this type of reaction. So you can see here we have single elements that come together to form one molecule, or sometimes we have different molecules that combine to form one molecule. So we have 2 or more reactants here that create one product. That's the pattern that happens in a synthesis reaction. So most of our types of reactions here we can relate to relationships. So when we're talking about a relationship in terms of a synthesis reaction, we would be starting off with 2 single people, and the product is them coming together to form a couple. So our definition for synthesis reaction is 2 or more reactants combining to form a single product. And with each type of these reactions, you will see a generic equation shown with just letters, and then a more specific equation. So for our generic equation here, we have A and B separately, and then they combine to form one molecule AB. So that's the pattern that you should see to recognize a synthesis reaction. So in our more specific example, we have magnesium that is combined with oxygen, and we get magnesium oxide. This is a reaction we will do soon in class, so you will be able to see it happen. Our next type of reaction is a decomposition reaction. So decomposition means to break down. So if you're looking at all of these chemical reactions over here, they all start with one product that is going to break into 2 or more smaller pieces. So our relationship analogy would be we start off with a couple and then they break up. So we then end up with 2 single people. So the definition for decomposition reaction is a single compound breaking down into 2 or more compounds or elements. So here for our generic equation, we have our molecule AB, and then it breaks in separately to A plus B. And then for the more specific equation, we have H2O2, which is hydrogen peroxide. It's something that most people have under their bathroom sinks. And that naturally breaks down over time into water and oxygen. Our next type of reaction is called a single replacement reaction. So if we're looking at all of these single replacement reactions, you'll see a compound and a single element in the reactants. So here we have a compound and a single element. Here's a compound and a single element. And then if you look at the products, the single element here has kicked something out of the molecule and taken its place, and then we have a different single molecule. So again, here the calcium has kicked aluminum out of the molecule and taken its place, and aluminum is by itself now. So our relationship analogy for this type of reaction is getting a little bit messier. We start off with a couple and a single guy. The single guy takes the place of the other guy in the relationship, and now the other guy is single. The definition for single replacement reactions is an atom or ion in a compound is replaced by another atom or ion. So here for our generic equation, we have a single atom and then a compound. This atom is going to kick out the other atom in the molecule and take its place. So now A was by itself here, and it's part of the molecule here. B was part of the molecule here, and here it's by itself. So our specific equation is listed there below. It's copper reacting with silver nitrate copper will kick silver out of the molecule and take its place. Our fourth type of chemical reaction is called a double replacement reaction. So if you look, these are all double replacement reactions. So we're starting off with two compounds, and they are made of either a metal and a nonmetal or a metal and a polyatomic ion. And if you look at the products, the metals have switched places with each other. So here, silver is with NO3 and sodium is with chlorine. On this side, silver is with chlorine and sodium is with NO3. So for the relationship analogy, you have two couples here, and for the products, they switch partners. So our definition of a double replacement reaction is the metals and nonmetals in two compounds switch places. So if you look here at the generic equation, we have AX plus BY, and our products then become AY plus BX. So the A goes in bonds with the Y, and the B goes in bonds with the X. They just switch places. And for the specific equation, we have silver nitrate plus potassium chloride, and that gives us potassium nitrate and silver chloride. Our fifth type of chemical reaction is a combustion reaction. And we don't have a relationship analogy for this one. A combustion is a little bit easier to remember because most of you are familiar with the term combustion, which means fire or explosion. Okay, so all of these types of reactions will have some sort of fire or explosion associated with them. So the definition of a combustion reaction is an element or a compound rapidly combines with oxygen to form carbon dioxide and water. As a result, heat is released. So here, for our generic equation, we have this hydrocarbon. We call a molecule that is made of carbon and hydrogen a hydrocarbon. And you have an X and a Y here, because remember, this is the generic equation. So carbon and hydrogen can bond together in many different ratios in many different ways. So those numbers will be replaced with any combination of numbers in a specific equation, but the rest of the equation looks very similar to an actual equation because the hydrocarbon will always combine with oxygen, and as products we will always get carbon dioxide and water. So it doesn't matter what type of hydrocarbon you have here. It could be CH4, it could be C3H8, it could be C5H12 like we have here. It's always going to combine with oxygen, and it's always going to produce CO2 and water. Okay, so let's go through some examples and try to figure out what types of reaction they are. So here in example 1, we have a single element combining with a compound, and this K is going to kick out the Mg, and it's going to be a part of the molecule now, and Mg is going to be by itself. That means that this is a single replacement reaction. Here is example 2. So we have C8H18, so that is a hydrocarbon that is combining with oxygen, and it produces carbon dioxide and water. So that tells us that this reaction is a combustion reaction. For example 3 here, we have two compounds, and if you look at the products, the compounds have switched places with each other. That means that this is a double replacement reaction. Example number 4, we have two single elements that are combining to form one product. That tells us that this is a synthesis reaction. And for example number 5, we have one molecule and it's breaking apart into its different pieces. That tells us that this is a decomposition reaction. So now that we have gone through the notes, you have some practice to work on. Let me know if you need help.